Hello viewers, I am Ashim Roy. Welcome to my educational channel, The Difference Between. Today, I shall try to explain the difference between the most beautiful optical natural phenomenon in the atmosphere, that is rainbow and aurora borealis. First, I consider the formation of rainbow. Now, the first condition for the formation of rainbow is that there must be clear sunshine, and number two, there must be rainfall. Just after rainfall, there will be lots of water droplets floating in the atmosphere, which acts like a prism. Let us consider the white light from the sun strikes at the point A, where the air is a rarer medium and water is a optically denser medium. Now, according to the laws of refraction, when light ray passes from rarer medium to denser medium, it will bend towards the normal. We know that white light is composed of 7 different colors having 7 different wavelengths. Therefore, during refraction, they will bend through different angles, and that's the reason for splitting up the white light, called the dispersion of the light. Now, when this light, that is refracted light, strikes the inner surface of the water droplet, then it should move out of the water droplet due to refraction. But here, the angle of incidence, I, sometimes will be more than IC. IC means the critical angle for the pair of media, water and air. In that case, or in this case, there will be total internal reflection instead of refraction. So, light ray will be totally internally reflected in this way, reflected. Now, at this point, again the light ray will move away from the normal, maintaining the laws of refraction. So, we see that the red light and violet light and other colored light in between the two are bent through different angles, and we can see a rainbow. Now, in the case of aurora borealis, the first condition is that there must be solar storm, solar flare. That is, sometimes the sun will be very much excited and it will eject tremendous amount of charged particles which moves away from the sun. This is actually the Earth, and moves almost at the speed of 2 into 10 to the power 6 miles per hour. Now, in this case, when these charged particles from the sun enter into the upper atmosphere, maybe ionosphere or like that, atmosphere, then these particles will strike the molecules, especially the primary gases, that is oxygen and nitrogen molecules. When it strikes these molecules, the molecules are extremely excited and gives off light, as in the case of heating. When you heat gas, say oxygen and nitrogen, it will give off different colored light, and we know that the what is called the oxygen, when heated, it will give green light, and the pink, purple and blue are given by roughly the nitrogen gas. Now, what happens when this charged particle try to enter into the atmosphere? Most of the charged, highly excited particles move away, but some particles will be captured by the magnetic field of the Earth, and Earth behaves like a magnet here. It has a magnetic field, strong magnetic field around it. So, according to the Lorentz force, that is F is equal to Q into E plus QV cross B, where Q is the charge, E is the electric field, V is the velocity of the particle, B is the magnetic field, is the total Lorentz force. The particle will bend and move towards the, especially towards the high magnetic zone, that is the north and south pole. Now what happens that when it moves towards north, it is called aurora borealis, but when it moves towards the south pole, it is called aurora australis. Now that's why we cannot see the aurora borealis from India, because it only occurs in the high magnetic zone, that is the North Pole and South Pole, near North Pole and South Pole. Now therefore the basic difference for the formation of rainbow and aurora borealis are: the first one, it needs the atmospheric refraction and white sunlight and rainfall, whereas in this case the what is called the solar storm and excited charged particles will be required from the sun. Now the equation for the total deflection of the light rays during the formation of rainbow is that D is equal to, D is total deflection or deviation, 180 degree plus 2I minus 4R. I is the angle of incidence in the first surface and R is the angle of refraction here. But in the case of aurora borealis, the equation is different, completely different. So these are the basic difference between the rainbow and aurora borealis. Thank you.